Welcome back to another explainer. Today, we're taking a pretty fascinating journey straight into the heart of the modern industrial bakery. Now, when most of us think of baking, we picture that standard stand mixer sitting on the kitchen counter, maybe whipping up a small batch of chocolate chip cookies or a single birthday cake. But industrial baking, man, that is an entirely different universe. We're talking about awe-inspiring, massive-scale machinery engineered to process literal tons of ingredients with pinpoint precision. So go ahead and throw out everything you know about that little bowl in your kitchen, because we're about to explore the heavy-duty world of industrial dough mixing. Okay, let's dive into this. I want you to really visualize the sheer physics involved here. Seriously, imagine trying to mix up to 1,000 kilograms. That's over 2,000 pounds of cookie dough. And you have to do it so uniformly that every single cookie off the line tastes exactly the same. No pressure, right? The massive mechanical force required to pull that off without completely destroying the ingredients or, overheating the dough. It's just a marvel of engineering. It's not just about spinning a giant whisk. It's literally about matching the exact physical properties of a dough to its perfect mechanical partner. So, to make sense of all this, here is our roadmap for the explainer. We're basically going to treat this like a dating profile taxonomy for baked goods. We're going to cover 1. The science of mixing, 2. Vertical and planetary mixers, 3. Horizontal and Z-blade mixers, 4. Spiral mixers for bread, 5. The power of continuous mixers, and finally 6. Finding that perfect match. All right, Section 1. The science of mixing. Before we introduce our eligible bachelors, the machines themselves, we really have to understand the baseline physics of what's actually happening inside those giant steel bowls. According to bakery science, there are basically 6 core functions happening when we mix. We're blending ingredients uniformly, dispersing solids into liquids, dissolving those solids, needing to hydrate the flour proteins and develop gluten, managing the temperature buildup that comes from all that intense mechanical friction, and finally aerating the mass to lower its density. Now here is the big secret of the industrial bakery. Absolutely no single machine on earth does all 6 of these perfectly, and that is exactly why matching the right mixer to the right product isn't just a good idea, it is absolutely crucial for the bakery. Okay, moving on to Section 2, vertical and planetary mixers. Now, what's really interesting about this slide is how these planetary mixers actually operate at an industrial scale. If bakery equipment had personalities, these guys would be the gentle, airy types designed for total finesse. The mixing tool moves in a planetary motion, orbiting the bowl while also spinning on its own axis. But the real magic? That happens when the mixing chamber is put under positive pressure during the cycle. This literally forces air into the batter, drastically increasing aeration and creating these perfect, tiny, uniform bubbles. So if you're making light, fluffy sponge cakes or biscuit creams, gluten development is your worst enemy. You want air, not chewiness. That makes the planetary mixer the absolute perfect match for those delicate treats. Closely related are the vertical spindle mixers. Notice the mobile dough tubs on wheels here? These are brilliant because the bowl is fully detachable. The vertical spindles are lowered into the tub, and their gentle, intermeshing action mixes everything together. And because the tub can just be wheeled right away, the dough can be rested, fermented, or moved down the production line without ever having to be violently hauled out of the bowl by hand. It's absolutely perfect for delicate doughs that really need time to cure and just cannot handle rough, high-speed extraction. All right, Section 3, horizontal and Z-blade mixers. But hey, what if you aren't making a delicate sponge cake? What if you're making a dense hard cracker? Well, for that, we leave the gentle aerators behind and bring in the heavy lifters. And this brilliantly illustrates the sheer mechanical power of a horizontal mixer using a Z-blade or sigma arm action. Just look at that W-shaped bowl at the bottom. Inside, 2 massive shafts are rotating in opposite directions. So instead of whisking, they're aggressively driving the dough towards the center, vigorously extruding, shearing, and tearing it apart. To really put this into perspective, think about the difference between gentle folding and high-energy shearing. For a flaky pastry, you want that gentle folding to completely avoid developing the gluten. But for a hard snack cracker, you absolutely need that tough gluten web. You literally have to beat the dough into submission. This high-energy shearing creates so much massive friction that the mixer actually has to be wrapped in a water-cooled jacket. Without it, the dough would literally cook itself during a 15-minute mixing cycle. Crazy, right? Just think about the massive scale and solid strength of this metal blade. I mean, it is a solid piece of heavy-duty industrial machinery built to withstand an incredible amount of torque. When a commercial bakery is churning out semi-sweet doughs, hard sweet biscuits, or tough crackers, a horizontal mixer equipped with these exact heavy-duty blades is their ultimate perfect match. Literally nothing else can develop the dough rapidly enough while handling up to 1,000 kilograms all at once. Moving on to Section 4, Spiral Mixers for Bread. Next up, we're moving to the machines specifically engineered for your everyday staples, like loaves of bread and hamburger buns. Now, bread dough is kind of unique. It requires serious energy, but a very specific type of stretching. Enter the industrial spiral mixer. Unlike the Planetary mixer where the bowl just sits there, here the bowl itself rotates on a vertical axis while the spiral-shaped tool spins against the inner circumference. This synchronized rotation creates a super specific kneading action. It basically stretches and folds the dough rather than just tearing it apart. This makes it the absolute perfect match for incorporating delicate ingredients, like dried fruits without crushing them into a paste, or for handling doughs with a weaker gluten structure that would just be completely destroyed by a harsh horizontal mixer. So the crucial point is, when you scale this technology up for mass production, we're talking tens of thousands of loaves a day, bakeries use what are called Chorleywood bread process, or CBP-compatible mixers. These are high-speed, high-energy variants that can fully develop bread dough in mere minutes. They're actually so advanced, they automatically control the atmospheric pressure inside the headspace of the mixer to manipulate the bread's exact cell structure. And they do all this while using cooling jackets to fight off that intense heat from the friction. Massive 24-hour bread plants rely entirely on these specific machines to keep our supermarket shelves stocked with pan breads and rolls. All right, Section 5, the power of continuous mixers. Now, everything we've talked about so far is batch mixing. You fill a bowl, you mix it, you empty it, and then you start the whole thing over. But what if you literally never want to stop? Let's move to and see how this builds into the automated continuous mixer. So instead of a bowl, it uses a central rotor spinning inside fixed stators. Both the rotor and the walls have a series of concentric pins. The batter is forced through this narrow, high-shear gauntlet in a continuous stream. Because there are 0 batches, the mixing action is incredibly efficient and yields a product with unmatched, flawless uniformity, hour after hour, day after day. The precision inside these continuous mixers is honestly staggering. They often break the mix into a highly specific automated sequence. First step, the mixer combines the minor ingredients, very carefully cutting the fat into just a portion of the flour. Then, moving further down the continuous tube, it adds the remaining flour in the final stage to lock in that perfect dough structure. So if you're running a massive, nonstop operation pumping out a single type of cookie or cracker, a continuous mixer isn't just a good choice, it is the absolute perfect match for your production line. Finally, Section 6, finding the perfect match. All right, we've seen the gentle aerators, the heavy-duty shearers, the bread specialists, and the non-stop continuous pipelines. At the end of the day, it all comes down to aligning the mechanical action with your desired final product. If you want light cakes or creams, you need the gentle whisking and high aeration of planetary or vertical mixers. Looking for the tough snap of a cracker, you need the vigorous extruding and shearing of a horizontal Z-blade mixer. If you want the soft, chewy crumb of a hamburger bun, you're going to rely on the rapid stretching and folding of a spiral or CBP mixer. And for endless rivers of perfectly uniform cookie dough, the uninterrupted high shear of a continuous mixer is your only choice. The exact texture of your favorite baked goods relies entirely on this very precise mechanical matchmaking. It really makes you appreciate the snack aisle a little bit more, doesn't it? The next time you bite into your favorite cookie or feel the snap of a cracker or enjoy the fluffiness of a piece of cake, ask yourself, what kind of massive mechanical force made this specific texture possible? Was it a gentle planetary orbit or a brutal horizontal shear? Thank you so much for joining me for this explainer. Keep looking closer at the science hiding right behind your everyday food, and I will see you next time.
Industrial Bakery Simplified.